Hello students, welcome back to the maths class. In our previous class, I have started a new chapter, three-dimensional geometry. There, we have studied about direction ratios and direction cosines. Okay, in today's class, we should learn the equation of line in space. Okay, if you remember, in your first year, we have already studied equation of line in two dimensions. We have studied different forms of equation of line, that is point slope form, 2-point form, intercept form, normal form, slope intercept form. Here we are going to study the equation of line in space. That is, we are going to study the equation of line in three dimensions and both in vector and in Cartesian form. Okay, so in two dimensions we have studied only the Cartesian form. Here we are going to study the equation of line in both vector form and Cartesian form. So here we are learning the equation of line, two equations of line, where the first one is equation of a line which passes through a given point and passes through a given vector. And the second equation which we are going to learn in the next class is equation of a line which passing through two given points. Okay. Now, in today's class, let us study this. That is equation of a line to a given point and parallel to a given vector. Okay. So here, this before I actually start with this is very important. This will be asked for 5 marks. Okay. So here, first thing you can see we have taken a line. This line is parallel to another vector, vector B, and this line is passing through a point A. So here, first thing, what is the data given here is let A be the position vector of the point A with respect to origin O. Okay, once we have the position vector A of the point A with respect to the origin O. Next, let N be the line which passes through the point A and this line is also parallel to the vector B. So the line L which is passing through the point A and it is also parallel to the vector B. Okay. And we know that let R be the position vector, let R be the position vector of the point R, of the point vector of the point. Let R be the position vector of the point P. These are the given data. That is, we are going to find the equation of a line. We are going to find the equation of this line L, which is passing through one point. We name that point to be as A. And also, this line is parallel to another vector, and that vector we have called it as vector B. Okay, so in order to find the equation of this line L, we have considered another point P on the same line. And this is the position for a point A, the position vector I considered it as A, and for the point B it is vector R. This is what we have written. A is the position vector of the point A with respect to the origin, and the line in which is passing through the point A and also parallel to the vector B. P is the point with the position vector vector R. Now if you see here, the line L is parallel to vector B. So I can say the vector AP, here you can take this vector AP. I am directing this vector AP in the direction of the vector B. This vector AP is also parallel to vector B. Yes, you can see the vector AP, only this vector AP is from starting, the initial point is A, the terminal point is C. P. The vector AP is parallel to vector B. So from this we know that vector is parallel to vector B. And we know that if any of the two vectors are parallel, we know how to find that is vector A is lambda times vector B. This we have studied in vector algebra. Yes? So we are going to use the same thing. So here we are telling that vector AB is parallel to vector B. So from this I can write vector AB is lambda times vector B. Okay, so vector AP is what? Vector AP is lambda times vector B. And we know how to write vector AP. Vector AP will be given as vector OP minus vector A. Again, vector AP which is equal to vector OP minus vector A. This we write it using triangular law of vector addition. So here you can see you have a triangle. So here in order to find the vector AP, I am going to use the triangular law of vector addition. That is vector OA plus vector AP is equal to vector OP. Okay, if I consider the two adjacent sides of a triangle taken in an order, the sum of these vectors will be taken in a reverse order. So vector OA plus AP, which is given by vector OP. From this I can write vector AP is equal to vector OP minus vector OA. Therefore, I am going to use that. So here vector AP is given by vector OP minus vector OA. Or simply you can remember when you have a vector in this form, that is initial point and the terminal point, you can write terminal point minus initial point, you get this one. Okay, this is equal to lambda times vector B. Now tell me what is the position vector of the point P? If you see the position vector of the point P, we have taken it as vector R. Therefore, I can write this as vector R minus. What is the position vector of the point A? The position vector of the point A is vector A, which is equal to lambda times vector B. I call this as equation number 1. Okay. This can also be written as vector R is equal to vector A plus lambda times vector B. So this is the equation of the line, equation of this line L, which is passing through the point A and parallel to the vector B. Okay, and this equation of the line we call it as vector equation, vector form of the equation of line. This is called as vector form of the equation of a line, which is passing through the point A and parallel to the vector B. Now we are going to find its Cartesian form. Okay, in order to find its Cartesian form, this is the vector form. So let us find the Cartesian form of this. So Cartesian form is given by. So here we have considered 2 points, point A and point B. Point P on the line L, where the Cartesian form of the point A, Cartesian coordinates are x, y, x1, y1, z1, and the Cartesian coordinates of the point P is x, y, and z. Okay, so if we know the Cartesian coordinates, we can write in vector. Okay, from that I can write vector A is equal to x1 I cap plus y1 j cap plus z1 k cap, and vector R is equal to xi cap plus yj cap plus zk cap. Okay. Then vector B is equal to this. For vector B, I am writing it as AI cap plus BJ cap plus CK cap. So let us substitute this in our equation number 1 in order to find its Cartesian form. Substituting these values in equation number 1. So vector R, what is your vector R? It is xi cap plus yj cap plus zk cap minus vector A x1 I cap plus y1 j cap plus z1 k cap, is equal to lambda times vector b. So lambda times vector b. Vector b is given by ai cap plus bj cap plus ck cap. Okay, therefore, here we are going to subtract two vectors, and we already know how to subtract the two vectors. So this is given by x minus x1 into I cap. Next, plus y minus y1 into j cap plus z minus z1 into k cap, which is equal to multiply the lambda, which is the scalar quantity inside. Therefore, you will get lambda times ai plus lambda times b into j cap plus lambda c into k cap. Now I am going to equate the coefficients of I cap, j cap and k cap. Equating coefficients of I cap, j cap and k cap. Therefore, if I equate the coefficients of I cap, j cap and k cap, see here what is the coefficient of I cap in the left hand side? It is x minus x1. And the coefficient of I cap in the right hand side, it is lambda times a. So, x minus x1, which is equal to lambda times a. Next, we have the coefficient of j cap in the left hand side is y minus y1 and in the right hand side is lambda times b. Therefore, y minus y1 is equal to lambda times b. And similarly, coefficient of k cap in the left hand side is z minus z1 and in the right hand side is lambda times c. Z minus z1 is equal to lambda times c. Therefore, this can be written as x minus x1 by a, which is equal to lambda, y minus y1 by b, which is equal to lambda, z minus z1 by c, which is equal to lambda. You can see all the three are equal to lambda. So I can write this as x minus x1 by a, which is equal to y minus y1 by b, which is equal to z minus z1 by c, which is equal to lambda. So this is your Cartesian form of the equation of the line, which is passing through the point A and parallel to the given vector. Whenever, if they ask the derivation of this, you should write it for both vector form and Cartesian form. Let us solve the problem on the equation of a line which we have studied in today's class. So here they have asked us to find the vector and Cartesian equation of a line which is passing through the point. Okay, please make sure that you remember this because once I complete 3D geometry, people get confused because you have a lot of formulas in this chapter. So if you remember this, here the equation of a line which is passing through a point and they're given parallel to the vector. So just now we have studied what is the equation of a line passing through a point and parallel to a given vector. So in that the vector form is given by vector r is equal to vector a plus lambda times vector b, and Cartesian form is given by x minus x1 by a, y minus y1 by a is equal to z minus z1 by c. So they have given a point. What was the point we have considered? We have considered a as a point, and the position vector of that point a, we call it as vector a. So this is our point. Okay, point A. For point A, we consider the position vector as vector A. So this was given by, okay, this we wrote it as x1 I cap plus y1 j cap plus z1 k cap. Okay, and which is parallel to the vector B. Which vector we took it as a parallel vector? We took the vector B as parallel vector, and we wrote the components of the vector B as ai cap plus bk cap plus pk cap. You should remember this. And always remember the position vector, it has its component form as xi cap plus yj cap plus zk cap. Okay, so let us solve this problem. So they have given a point. So point means this will be for the vector A, and we know already how to write a vector when its Cartesian coordinates is given. So this is written as phi I cap plus 2j cap minus 4k cap. Phi 2 minus 4 they have given. So this is phi I cap plus 2j cap minus 4k cap. Parallel to the vector. Parallel to the vector means it is understood the That is for vector B. Vector B is given by bi cap plus 2j cap minus 8k cap. We need to find what? We need to find the equation of line both in vector form and Cartesian form. So vector form. What is the formula? Vector form is given by vector R is equal to vector A plus lambda times vector B. So vector A, which is 5i cap plus 2j cap minus 4k cap plus lambda times vector B. Vector B is 3i cap plus 2j cap minus 8k cap. That's all. Okay, this much if you write, you get 1 mark. This is 2 marks problem. Okay, next is Cartesian form. So Cartesian form means we know that the Cartesian form is given by x minus x1 by a, which is equal to y minus y1 by b, which is equal to z minus z1 by c. Okay, so x minus x1 by a. Now we know that vector A is given by what? X1, y1, and z1. This is a general, okay, general form. And vector B is given by a, b, c. So this will be your. This is nothing but a1i cap plus. Sorry, this is x1i cap plus x1i cap plus y1k cap plus z1k cap. And this is your ai cap plus bk cap plus ck cap. So just compare and substitute the values. So what is x1 is given by? X1 is given by 5. So x minus x1, it is 5 divided by a. What is the value of a? It is 3. This is equal to y minus y1. What is the value of y1? It is 2 divided by b. What is b is given by? It is 2 again. Z minus Z1. So Z minus Z1. What is the value of Z1? It is minus 4. So this becomes minus 4. Z1 value is minus 4. 4 divided by C. C is given by minus 8. Okay. C is given by minus 8. Therefore, simplifying this, x minus 5 by 3 is equal to y minus 2 by 2, which is equal to z plus 4 divided by minus 8. And this is your Cartesian form of the equation of a line for a given point 5 to minus 4, and which is parallel to the vector 3i cap plus 2j cap minus 8k cap. Next problem, again, you have a similar problem here. Here, we need to find the equation of line both in vector and Cartesian form. Point is given and also the vector which is parallel to the line is given. So when they have given points, that is for vector A. So it can be written as 1i cap plus 2j cap plus 3k cap. Okay, so this is nothing but x1i cap plus y1k cap plus z1k cap. Okay, next. They have given which is parallel to the vector 3i cap plus 2j cap minus 2k cap. That is vector B 3i cap plus 2j cap minus 2k cap. Therefore, this is nothing but ai cap plus bj cap plus ck cap. So let us write its vector form. So vector form is given by vector R is equal to vector A plus lambda times vector B. Vector A is 1i cap plus 2j cap plus 3k cap plus lambda times vector B. Vector B is 3i cap plus 2j cap minus 2k cap. So simplifying, now for Cartesian form we need to find, in order to find the Cartesian form, x minus x1 by a, which is equal to y minus y1 by b, which is equal to z minus z1 by c. So x minus x1 by a, x minus, what is the value of x1? It is 1 divided by a is nothing but 3, which is equal to y minus y1 minus y1 value is 2. What is the value of b? B value is 2. Just compare this, okay, which is equal to z minus z1. What is the value of z1? It is 3 divided by c. That is c value is minus 2. Therefore, this is the vector and Cartesian form for the given question. In this question, we need to find the vector and Cartesian form of the equation of a line that is passing through a point with position vector. So here, they have given directly the position vector of the point. In the previous problem, they are giving the Cartesian coordinate. We used to write it in the form of a vector. Now here they are directly given. So vector A is given by what? 2I cap minus j cap plus 4k cap. So the general form is x1I cap plus y1 j cap plus z1 k. And this is the direction. So they have given the vector and they are telling in the direction, but they have not given the parallel vector. Are they not given? No, they have given the parallel vector. Why? Why? Because see, when I was explaining this derivation, we have seen that vector AP, I have told that vector AP is in the same direction of vector B. Means it is understood that when they are given and this is the same direction, it is understood that it is for vector B. So this is I cap plus 2j cap minus k cap, which is equal to ai cap plus bj cap plus c cap. Therefore, the vector form, we know that vector form is given by vector r is equal to vector a plus lambda times vector b. So vector A is 2I cap minus j plus 4k cap plus lambda times vector B, which is given by I cap plus 2k cap minus k cap. Okay, and the Cartesian form, which is given by x minus x1 by a, which is equal to y minus y1 by b, which is equal to z minus z1 by c. So x minus, what is the value of x1? x1 is 2. And a, the value of a is what? The coefficient of I cap in the vector b. It is 1, which is equal to y minus y1 by b. Means y minus, what is the y1 value? What is minus 1? So y minus of minus 1 divided by b. b is given by 2, which is equal to z minus z1. z1 value is 4 divided by c. c is given by minus 1. Therefore, simplifying this, this is x minus 2 by 1, which is equal to y plus 1 by 2, which is equal to z minus 4 by minus 1. Next question. The Cartesian equation of a line is given. Write its vector form. So, they are given this form. We need to write in the form of a vector. In order to write it in the form of a vector, we need to know what is vector A and vector B. So first, let us consider the Cartesian form which is given. So it is x minus 5 by b plus y minus 4 by 7 is equal to z minus 6 by 2. Okay, let us compare this with the general form. This general Cartesian form, that is x minus x1 by a, which is equal to y minus y1 by b, which is equal to z minus z1 by c. Okay, comparing this, see here we need x minus x1. Always we should have minus here. But here we have plus. So this can be written as y minus of minus 4. So this I can write it as x minus 5 by 3, which is equal to y minus of minus 4 by 7, which is equal to z minus 6 by 2. Now it has reduced in the general form. See x minus x1 in this form only it is there. So we can now know what is x1, y1, z1 and also what is abc. Once I know x1, y1, z1 and abc, I can easily write what is vector A and vector B. What is the general form of vector A? It is x1 I cap plus y1 j cap plus z1 b. So now this will be given, right? What is your x1 here? Compare. x1 is given by 5. y1 is given by minus 4, z1 is given by 6. Therefore, this is can be written as 5i cap minus 4j cap plus 6k cap. I hope you have understood. What we have done is we have considered the Cartesian form which is given. We have reduced it into the general form. That is general. We have compared with the general Cartesian form. Okay, once we have compared, we are able to find what are the values of x1, y1, z1. So once we know what is x1, y1, z1, we can easily write what is vector A, because vector A is given by x1 I cap plus y1 j cap plus z1 k. Now similarly, in order to write for vector B, which is given by a I cap plus b j cap plus c k, which is equal to, what is your a, b, c? Can you compare and tell me? It is A is given by B is given by C, and sorry, B is given by 7 and C is given by 2. Therefore, this is can be written as 3I cap plus 7J cap plus 2K. What we need to write? We need to find its vector form. So vector form is given by vector R is equal to vector A plus lambda times vector B. Therefore, this is equal to vector 5I cap plus minus 4J cap plus 6K cap plus lambda times 3I cap plus 7J cap plus 2K cap. Okay, this is the vector form for the given Cartesian form. Next problem, a similar problem. So they have given in the Cartesian form, you should write it in vector form. So the general Cartesian form is x minus x1 by a, which is equal to y minus y1 by b, which is equal to z minus z1 by c. And they have already given in the question, let us write that x plus 3 by 2, which is equal to y minus 5 by 4, which is equal to z plus 6 by 2. Let us compare this and let us try to reduce in the general form. So here, this should be written as x plus 3 there given, so it should be x minus of minus 3 by 2, which is equal to y minus 5 by 4, which is equal to z. Again, you have plus, so this can be written as z minus of minus 6 by 2. Why we are doing this? In order to write this in the form of general form. Okay, in order to reduce the given Cartesian form into general form. So once we have seen this, we now know what are the values of x1, y1, z1 and a, b, c. So vector A, which is given by x1 I cap plus y1 j cap plus z1 k cap, which is nothing but what is the value of x1? Compare this equation with this equation. x1 is given by minus 3. So I cap plus y1. y1 is given by only 5. Don't get confused. It's not minus 5. It's only 5 plus 5. 5 cap plus z1. What is z1 is given by? Z1 is given by minus 6. So minus 6 k. Similarly, let us find what is vector B, which is ai cap plus bj cap plus ck cap. Therefore, comparing a value is 2, b is 4, c is 2. Therefore, 2I cap plus 4j cap plus 2k. Okay. Now we need to write the vector form. Where vector form is given by vector R is equal to vector A plus lambda times vector B. Therefore, this is equal to vector A, which is given by minus 3I cap plus 5j cap minus 6k cap plus lambda times vector B is 2I cap plus 4j cap plus 2k cap. Understood? Next question, we need to find the Cartesian equation of the line which is passing through the point. So again, they have given the point, means that is for vector A. So let us write the vector A. So it is given by 2I cap plus 4j cap minus 5k cap. Next, and parallel to the given line. So means it is for vector B. So here, parallel to the line they have given, but that line's Cartesian equation they have given, but they have not given directly what is vector B. We need to first find what is vector B with the help of the Cartesian form of the equation of the line. So let us first write that x plus 3 divided by 3, which is equal to 1 minus 4 by 5, which is equal to z plus 8 by 6. Okay, reduce in the general form. So x minus of minus 3 by 3, which is equal to y minus 4 by 5, is z minus of minus 3 by 6. From this, again, we need only the vector b. Okay, so here vector b is given by ai cap plus bj cap plus ck cap. So when you compare this with the general form, A, B, C are given by 3, 5 and 6. Okay. Vector B is AI cap plus BJ cap plus CK cap. So the value of A is 3, the value of B is 5, the value of C is 6. So from this I can write vector B as 3I cap plus 5J cap plus 6K cap. Okay. What So now we know what is vector A and vector B. Now let us find its Cartesian form. So Cartesian form is x minus x1 by A, which is equal to y minus y1 by B, which is equal to z minus z1 by C. Okay, so here x minus x1, what is the value of x1? It is, see, the scalar components of vector A is x1 minus z1. So it is minus 2 is your x1, this is your x1, y1 and z1. So minus 2 by A. What is A? It is 3, which is equal to y minus y1, 4 divided by B. B is given by 5, which is equal to z minus z1, which is minus 5 divided by C is 6. Simplifying, so x plus 2 by 3 is equal to y minus 4 by 5, which is z plus 5 by 6. This is the Cartesian form. Here, if they ask, we can even find its vector form because we already know what is vector A and vector B. So this completes the problem on equation of a line which is passing through a given point and parallel to a given vector. So you should remember the derivation and also its vector form and Cartesian form. In the next class, let us learn how to derive the equations. Let us derive the equation of a line which is passing through 2 points.